Hi, today we'll understand singleton design pattern, and to understand singleton design pattern we will break it into three parts. First would be a simple singleton design pattern, second would be design pattern in a multi-thread environment, and the third will optimize it further and we'll learn about a concept called double check locking. Okay, but before we start with singleton design pattern, let's understand what are design patterns. And before understanding what are design patterns, we should ask a question: why do we need design patterns? So this will be a common concept or a flow before understanding any new concept. First of all, we should ask the question: why do we need it? We already have so many concepts, so why one more concept to understand? So understanding a new concept is like adding one more tool to your armory, so that when you face certain situation, you could use this particular tool which could solve this a particular problem in the best way. To illustrate it further, I will talk about a phrase that we talk mostly in our day-to-day life. We always talk about why reinvent the wheel, right? Why reinvent the wheel? So we all understand the meaning of this. When we have a solution to a common problem already, so we tend to use it because we should not spend much time building it from scratch again. Okay, so that's what are design patterns. There are certain problems which have been solved already and we can use this solution instead of rebuilding everything from scratch. It makes our life easier and the development becomes faster. So with our understanding about design patterns, now let's come back to our topic, that's singleton design pattern. So why do we need singleton design patterns? So certain times during our software development life cycle, we come across use cases where we need to restrict the object creation to just one object, where we need only one instance of an object. So I'll give you examples from software world. So in places where multiple processes are trying to get a DB connection, right? Or when we are logging, or in physical world when using printers, right? So there are multiple processes or multiple people trying to access a resource at the same time. So we need one single point of control which can control the access. So that's where, because if we have more than one control that controlling entity, then there will be an extra layer of complexity where we will need to synchronize multiple controllers. So instead of that, we make our interface simpler and we have only one interface which will take all the user inputs and synchronize them and interact with the critical resource in one way, not one way, one interface. So that interface is provided by a singleton and we don't need multiple interfaces there. Okay, so let me show you this via a code, and most of the code that I'll be going through would be in Python. Okay, so I hope you can see my screen and let's check. So we will talk about the logging thing first. Okay, so I'll show you the code from a standard library, a standard Python library, where they are using a logging service. This is a logging service. This is a standard library where you can install it from pip install logging service, and this is the code from there. Right? So I'll just read it for you. So this logging service, this is the logging service class, and this is a singleton logger. Use that single instance for multiple modules to log to one place. Methods are debug, warn, and info and error, whatever. But this is the main thing, a singleton logger. Okay, and how does it ensure in Python that's the singleton? What's the way to do it? So we have a concept called meta classes. So in short, I won't go in detail about meta classes because that's another topic in itself. But in short, meta classes are classes which define the behavior of a class. Okay, because everything is an object in Python, we all know that. So when we need to define certain things about a class, so we need to use a concept called meta classes which exists in Python. Probably I'll make some other video talking about meta classes someday. Okay, so let's continue here, but I'll highlight the important parts here. So if you see the constructor of this is the init index constructor in Python. So we have a variable called, this is the instance variable, CLS stands for class. So CLS dot instance is initially set to none. So as soon as this class is instantiated, this will be set to none. Now this is the important part here. We override the call method. So call method, this is another concept in Python. I'll talk about it, but I assume we'll have some basic understanding of it. But this call method is used to make any Python object callable. So whenever you want to make an object callable in Python, we put a curly braces around an object and it becomes callable. So that time we have to override this dunder method call, and this will make this object callable. So this is a short introduction about call. Okay, and in that callable method, in this call and dunder call method, we have the main logic here. So here, to restrict the object creation to just one object, what do we do is we check whether the instance is not none, and if it's not none, we return the instance as it is. But if it's none, we go ahead and create this instance and set that instance. So when we call this thing, so this super and this class dot call, this will call the constructor of this logging service here, and the init of this method of this class would be called, and the instance will be instantiated, will be given the value or assigned the value of this class's object, and then we return that instance here. Okay, so this is a very simple implementation of a singleton. Here this way we restrict, so we check that if the object is not created, only then we create. If the object is created, then it won't be created. This way we ensure that we have only one instance of that class. And the second point is, since we have only one instance of that class, every time you instantiate or try to create an object of this logging service class, create an object of this logging service class, the same instance will be returned. So that way we ensure that we have only one object of this class. Now let's come and check the multi-threaded version of this singleton. Here it's just the same thing, but in a singleton, in a multi-thread environment, there's a concept of locking. So wherever there is a critical section, right? So in a multi-thread environment, we need to protect that critical section so that multiple threads don't come and access the same critical section at the same time. So whenever one thread is executing that critical section, that thread needs to lock that critical section and then start the execution, so that two threads don't write it and create garbage values there. Okay, so that's where we use this concept called locking. So here in this section, you see a thread is acquiring a lock. This count I have just put it for just my debugging purpose. We can comment this out. Okay, and then it acquires, one of the threads will acquire the lock, and first it will acquire a lock, and then again it will check for whether the instance is there or not. If it's not there, only then it will come and create the object, as we saw in the previous example. Okay, and it will be, and the class dot instance, the similar instance, which is you can see here, this is the meta class of this singleton class. You can see that this is none initially, and if it has not been instantiated currently, it will be created for the first time here, and then it will be assigned the value, and finally we return from here. So the main important thing here is the locking part. So before creating the object, we check whether it has been created already. So any thread which comes and acquires the lock, that checks whether the object is already created or not, and if it's not created, only then the object will be created, and then it will be initialized, the instance will be set to that value, the value will be set, and we will use it for all future purposes. But there is one more issue here. It can be further optimized. So when there are multiple threads, every time they will come and try to, whenever they want to get an instance of this object, right, every time they will come and try to get this lock, and this is overhead. When multiple threads are coming and trying to get a lock, right, you are going and coming and checking something, whether I have the permission to get this object or not. So then I can come to the, I talked about the simple singleton, which was here in this example. The second thing which I talked about was the multi-thread environment, where we acquire a lock here and then try to create an object of the singleton instance. And the third concept, which will the further optimized version of this singleton, multi-thread singleton is a double check locking. So since you got the point here that multiple threads will be unnecessarily checking every time whether the first they will check get the lock and then check whether the object is created or not. This is the waste of resources, waste of time for all the threads basically to come and get a lock and then check whether the instance is there or not. So what we do is before acquiring the lock, we check whether the instance is there or not. If the instance is already there, why do we need to acquire a lock and then check? So if the instance is already present, we just return that instance. If some thread has already created that instance, we just return that instance from here itself. If it's not present, only then we go inside and acquire a lock. Okay, so this extra optimization here is called a double check locking. So this is the most that would be expected for you to understand in a singleton. Okay, to sum up again, first thing, this why this logging example I showed you, this is a simple singleton where we check whether the object is created or not, and if it's not created, only then we create. And every time when we try to create a new object of this logging service whose meta class is meta logging singleton, we get the same object back which has been initialized the very first time. Okay, which comes from this logic here. Okay, and the second thing was the multi-thread example where we come here first and check whether get a lock first and then check whether the object is created or not. So this lock is for the critical section. Okay, and only then, and there is this code is similar to the earlier example. So the only extra thing is we acquire a lock here in a multi-thread environment. And the third thing is it's costly operation to get a lock, and this is unnecessarily all the threads are trying to get a lock and then check whether the object instance is already present or not. Instead of that, we optimize it further and we check whether the object instance is already present or not, and we return the object instance if it has been created already. So this saves us executing this and waiting on this lock part and this code. So that is all. If you want, I can just run it and show it to you how it looks. So here, if you see, come down further in this example, this is the singleton method. So I have created 5 threads, and then in this test singleton method, I'll create an object of the singleton, and with passing the value will be a string, and then singleton in its constructor, I'm setting its value to the value. It's a string value. Okay, and all the threads will be executing the same method, and they will set the value of the singleton with the value what I'll be sending in the thread, and then they'll print that what is the current thread name and the singleton value. So the expectation is once one of the threads sets the value of this value, it shouldn't change, and all the threads should print the same value of this, means of the value of the singleton dot value here. Okay, so I have run it already. I'll expand it here. So if you can see right there, this is process 1. Okay, this is the first thread which takes an argument foo, sets the value as foo, then the bar, and then there are like 3 more kk, ky, 2k. So these are just text examples. Okay, so these are the 5 threads here, and I have run it already. I'll show you the sample output here. So acquired lock, so entering critical section. So one of the threads, it acquired a lock and it is entering this critical section. So this is coming from here. So don't worry about this color or this force, and this is coming from a library which gives colors to this print statements. So that's why you see a blue print here. There's nothing special about my terminal. So it gets a lock, and then it creates a new instance, and then the thread 1 which is calling singleton method, and then you see that thread 4 is executed, and then it prints the value foo. Okay, then again there are other threads also which have entered the critical section already, but you see they won't be creating a new instance. When they come here, they have already entered a critical section, but they are not executing this statement because this instance has already been instantiated. So they got a lock, but they won't do. So you see right, foo foo foo. So this thing, then thread 3 executed, and thread 2 executed, and thread 5 executed, but this print was again out of sync, out of order. So again, every time you run it multiple times, you will get different outputs here. You can check that. Okay, So this was an example to show you. I'll share the code in the description here, okay, so that you can refer it and play around with this. And that's all for Singleton. Thank you.